Well, hello, geometers and seekers of general truths. In this video, we will conclude our lesson on the sine and cosine ratios by evaluating exact values for the sine and cosine of 30-degree angles and 60-degree angles. Because these are special angles, the only way that we can calculate exact values is if we use the 30, 60, 90 triangle theorem. So I've pasted it here so that we can see the hypotenuse is twice as long as the shorter leg, and the longer leg is square root of 3 times as long as the shorter leg. And I've drawn my triangle here. I have a 30-degree, 60-degree, and 90-degree angle, and I've named the side lengths x, y, z because we don't really know what those values are in any particular triangle. We represent them with variables. So let's start here with the cosine of 30 degrees. So remember, cosine is the leg adjacent, which in this 30-degree, using this 30-degree angle, we have the adjacent leg here is y, and the hypotenuse here is z. And I'm just going to keep on going in the first two examples here. For the sine ratio, the opposite leg is x, and the hypotenuse is still z. For the cosine of 60, so using 60 degrees as our reference, the adjacent leg is x, and the hypotenuse is z. And finally, for the sine of 60 degrees, using 60 as our reference, the opposite leg is y, and the hypotenuse is z. Now, first of all, you should see that some of these values are the same. The cosine of 30 and the sine of 60 are the same. The cosine of 60 and the sine of 30 are the same. So there's a bit of a relation there that we will explore a little bit later on. And then second, I want to point out that, we have a bunch of variables in our fractions here, and that doesn't lead us very far. So we're going to have to use this theorem in order for us to figure out the exact numerical values. So let's look at this again. The hypotenuse is twice as long as the shorter leg. Well, here's the hypotenuse. It's z. It's opposite the 90-degree angle. Twice as long as the shorter leg. So the shorter leg here is x. Okay? So that means we can say that z is equal to 2x. And the longer leg, so that's this leg here, that's y. The longer leg is opposite the 60-degree angle, is square root of 3 times as long as the shorter leg. So y here is equal to the square root of 3 times x. Now, let's put all of this together and make some substitutions here. So in our first problem here, the cosine of 30 is equal to y. And so we're going to write everything in terms of x because that gives us everything as a single variable, and we can do some simplification much easier. So y is the square root of 3 times x, and z is 2x. Right, z is 2x. So the x's cancel out, and what we are left with is the square root of 3 over 2. That means the cosine of 30 is equal to the square root of 3 over 2. Now you can see here that the sine of 60 is equal to the same thing. So the sine of 60 is also equal to y over z, which when we work out all of the details, it's going to be the square root of 3 over 2. Let's go on now to the sine of 30 degrees, which is x. If we're using 30 here as our reference, the opposite leg is x, and the adjacent leg, the hypotenuse is z. So we can rewrite this with a substitution, x over z, but we know that z is equal to 2x. So the x's cancel, and all we're left with here is 1 over 2. Okay, so we can say that the sine of 30 is equal to 1/2, And by that exact same reasoning, we know from before that the cosine of 60 is equal to x over z, which is the same thing as the sine of 30. So this is equal to 1/2 as well. And now we've completed our study of the special triangles, the special angles, and the trigonometric ratios. We know the exact values for the cosine and sine and tangent of all of the special angles, 45, 30, and 60 degrees. At some point, you're going to have to memorize all of these, but for right now, what you really should focus on is understanding why these are true. And later on, if you're preparing for some sort of assessment, it's worthwhile to just memorize what these values are equal to. As always, thank you for working hard. Keep struggling. Keep thinking through all of the problems. Ask for help whenever you need it, and have a wonderful day.